So in this video we're going to look at linear combinations of vectors. Now in this example here I've drawn up three vectors on this diagram, and these three vectors are all in the two-dimensional plane with real numbers. And vector A is 10 and 3, so x is 10 and 3 for y, so that's this large vector here. I've got vector 1 is 3, 1. That's this one here, almost similar to the vector A, but it's just a little bit more further upwards. And vector 2 is 2, 5, that's this one here. And they're all going in the... Now what we're looking for is, can we make vector A from linear combination of vector 1 and vector 2. Now we can see here, there's vector 1 and there's vector 2. Now if I just draw vector 1 and 2 together, I could get, if I can just try and do this justice by doing freehand, this vector 2 added onto vector 1 will go somewhere like that. And then I would end up with this vector here as my resultant vector. Now the same, if I did the same with vector 2 and put vector 1 on vector 2, that would then go this way and it would end up in the same place. Now that's not going to reach the point where vector A is. So what I need to do is to find some combination where they can reach the same point. So for example, if vector 1, what I can do to keep this vector, I can multiply it by a scalar. So if I was to keep going in this direction, it would end up somewhere out here, and that would be close to vector A. And then vector 2, I would need some combination of that to get it to go to there, but it looks like it would have to be the reverse of this vector. It would have to be a negative vector 2. So that's what I'm going to need. So that could be some scalar of vector 1 and that could be some scalar of vector 2. But what we need to know is, what is the value of these scalars? So for example, if I wrote vector A, that is 10, 3, and I want that to equal vector 1, which is 3, 1, and plus vector 2, which is 2, 5, and I'm going to need some scalar multiple to multiply these by. So I could call this one alpha and this one beta. So this is just the name of the vector. So that's kind of what we're looking at here. Now to write this properly, because it's a little bit of abusive notation there, to write this properly, what I'm going to do is do a setup. So I'm going to do my vector 10, 3, then that would equal alpha times vector 1 plus beta vector 2. Now, sorry, vector 2, that's my vector 2 there. Now, alpha and beta are going to be real numbers. So alpha and beta are both going to be real numbers. Okay. Now, what I need to do is work out how to calculate these. So my next line of working, I'm going to put 10, 3 equals alpha times the vector 3, 1 plus beta the vector 2, 5. And my goal is to find the value of these alpha and beta constants. Now what we can do is we can do vector addition. So we've got 10 here for the x component, and it's going to be alpha times 3 and beta times 2. So I can, first of all, I can write that. So 10 equals alpha times 3 plus beta times 2. And then the same here, 3 would equal alpha times 1 plus beta times 5. So 3 equals alpha times 1 plus beta times 5. Now we're going to have here two simultaneous equations because I've got two equations and two unknowns. So let's set that up in that manner. So now I'll have 10 equals 3 alpha plus 2 beta, and 3 equals alpha plus 5 beta. Okay, so if I call this equation 1 and this equation 2. So what I want to do is to find one of the variables to have the same amount and then add or subtract accordingly. Well, if I multiply this one by 3, equation 2, I can get 3 alpha. So let's do that. So equation 2 times 3. So that would be 9 equals 3 alpha plus 15 beta. Okay, now let's write equation 1 next to it. So then 10 equals 3 alpha plus 2 beta. Okay, now to get these alphas to disappear so I can get beta on its own, let's just subtract the 2. So this is equation 1. Subtract the 2. 9 minus 10. That gives me minus 1. 3 alpha minus 3 alpha disappears. 15 beta minus 2 beta, that equals 13 beta. So now to get beta on its own, I can see straight away beta equals minus 1 over 13. So that's beta taken care of. So now I need to find alpha. So let's find alpha. Well, if I know what beta is, I can substitute into one of these equations and then I've got my beta. So let's do that in this line down here. Let's plug it into equation 1. So equation 1, I've got 10 equals 3 alpha plus 2 beta. Beta's minus 1 over 13. So 10 equals 3 alpha minus 2 over 13. So that's the correct value there for my beta. So now I just need to solve for alpha. So if I change that to over 13, so now I've got 130 over 13 minus 2 over 13. Well, I can add 2 over 13 if I bring it to the other side. So plus 2 over 13, that equals 3 alpha. So let's simplify this up. 132 over 13 equals 3 alpha. Divide everybody by 3. So then I've got 132 divided by 3. That's going to give me 44. So that equals alpha. Okay, right. So now what I can do is I can just check my values and see if that makes a linear combination of these vectors. So let's plug that into this part here. So let's just see what happens into this one. So I've got 10, 3. That equals alpha, which is 44 over 13, times my vector v1, which is 3, 1, plus my beta, which is minus 1 over 13. So I can change this to a minus 1 over 13 times 2, 5. Okay, right. Hopefully we will get this correct vector on this side. So 44 over 13 times 3. So that gives me then 132 over 13. This one times 44 over 13 times 1 just gives 44 over 13. And then 1 over 13, so it gives me 2 over 13. And then here, 5 times 5, I've got 5 over 13. Okay, so let's check this out. 132 minus 2 over 13 gives me 130 over 13. And 44 over 13 minus 5 over 13 gives me 39 over 13. And know my 13 times table, that gives me 10, that gives me 3. So there we go. So that's our linear combination. So here we've got alpha equals 44 over 13 and beta equals minus 1 over 13. And that will give us our linear combination with these two vectors to get the vector A. Okay.